Learners and viewers, welcome to the session for Quantitative Analysis for Managerial Applications, MMPC 005. First of all, I would like to tell you that this course is related to mathematical analysis, mathematical operations. So in block 1, that is related to data collection and analysis. We will be doing analysis of what? We will be doing the analysis for the data what we have collected. Unit 1 is for collection of data. Unit 2 is presentation of data. Unit 3 is measures of central tendency. And Unit 4 is for measure of variation and skewness. So we will start with Unit 1, that is collection of data. To make a decision in any business situation, we need data. Facts expressed in quantitative form can be termed as data. Success of any statistical investigation depends on the availability of accurate and reliable data. These depends on the appropriateness of the method chosen for data collection. Therefore, collection is a very basic activity in decision making. Here, we will be studying the different methods that are used for collecting data. Data may be classified either as primary data or secondary data. Now the question arises, what is primary data? Data used in statistical study is termed as either primary or secondary, depending upon whether it was collected specifically for the study in question or for some other purpose. When the data is used in a statistical study, is collected under the control and supervision of the investigation. Such type of data is referred as primary data. Or rather, we can say that data which is collected afresh. When the data is not collected by the investigator, but it is derived from other sources, then such data is referred as secondary data. The difference between primary and secondary data is only the terms of degree. For example, data which is primary in the hands of one becomes secondary in the hands of others. That means recorded. What are the methods of collecting primary data? Primary data may either be collected through observation method or through questionnaire method. In observation method, the investigator asks no questions, but he simply observes the phenomena under consideration and records the necessary data. Sometimes individuals make the observation. On the other occasion, mechanical and electronic devices do the job. It may be difficult to produce accurate data. Physical difficulties on the part of the observer may result in errors. Because of these limitations in the observation method, the questionnaire method is most widely used for collecting data. In the questionnaire method, the investigator draws up a questionnaire containing all the relevant questions which he wants to ask from the respondent and accordingly records the responses. Questionnaire method may be conducted through personal interview or by mail or by telephone. We will start with personal interviews. Here in this method, the interviewer sits face to face with the respondent and records his responses. In this method, the information is likely to be more accurate and reliable because the interviewer can clear up his doubts and cross-checks the respondent. This method is time-consuming and can be very costly if the number of respondents is large and widely distributed. Second method is mail questionnaire. In this method, a list of questions is prepared and is mailed to the respondent. The respondent are expected to fill the questionnaire and send it back to the investigator. This method can be easily adopted where the field of investigation is very vast and the respondents are spread over a wide geographical area. But this method can be adopted only where the respondents are literate and can understand written questions and answer them correctly. Third method is telephone. In this method, the investigators ask the relevant questions from the respondent over the telephone. This method is less expensive, but it has limited application, since only those respondents can be interviewed who have telephones. Moreover, very few questions can be asked on the telephone. That is its limitation. The questionnaire method is very efficient and fast method of collecting data, but it has a very serious limitation, and it may be extremely difficult to collect data on certain sensitive aspects, such as income, age, or personal details, which the respondent may not be willing to share with the investigator. This is so with other methods also. People may be interpreted the questions differently, and consequently there may be errors and inaccuracies in data collection. Once the investigator has decided to use the questionnaire method, the next step is to draw the design of the survey. A survey design involves the following steps. Number one is designing a questionnaire. Number two is pre-testing a questionnaire. And number three is editing the primary data. So we will see one by one. Designing of questionnaire. The success of collecting data through a questionnaire depends mainly on how skillfully and imaginatively the questionnaire has been designed. A badly designed questionnaire will never be able to gather the relevant data. Some of the important points to keep in mind in designing a questionnaire are covering letter. Every questionnaire should contain a covering letter. The covering letter should highlight the purpose of the study and assure the respondent that all responses will be kept confidential. The objectives of the study and the questionnaire design should be such that the respondent derives a sense of satisfaction through his involvement. Number of questions should be kept to be minimum. Fewer the question, the greater the chances of getting better responses, and having all the questions answered. Otherwise, the respondent may feel disinterested and provide inaccurate answers, particularly towards the end of the questionnaire. As a rough indication, the number of questions should be between 50 to 40. In case of number of questions is more than 25, it is desirable that the questionnaire should be divided into various parts to ensure clarity. Number three is questions should be simple, short, and ambiguous. The questions should be simple, short, easy to understand, and such that their answers are ambiguous. For example, if the questions are you literate? The respondent may have doubt about the meaning of literacy. To some, literacy may mean a university degree, whereas to others, even the capacity to read and write may mean literacy. Now we have to be very much specific what we want to. Questions of sensitive or personal nature should be avoided. The question should not be such as would require the respondents to disclose any private or personal or confidential information. For example, questions related to sales, profits, material, happiness, etc. should be avoided as far as possible, because nobody is going to tell it correctly. Answers to questions should not require calculation. The question should be framed in such a way that the answers do not require any sort of calculation. Number six, logical arrangement of the questions. The questions should be logically arranged so that there is continuity of responses and the respondent does not feel the need to refer back to the previous question. It is desirable that the questionnaire should begin with some introductory questions, followed by vital questions, crucial to the survey, and ending up with some light questions so that the overall impression of the respondent is a happy one. Cross-checks and footnotes. The questionnaire should contain some such questions which act as a cross-check to the reliability of the information provided. For example, when a question related to income is asked, it is desirable to include a question, are you an income tax assessee? Now comes the second step is the pre-testing of the questionnaire. Once the questionnaire has been designed, it is important to pre-test it. A pre-testing of a questionnaire is also known as pilot survey because it precedes the main survey work. Pre-testing allows rectification of problems, inconsistencies, and repetition, etc. If changes are required, the necessary modifications can be made before administering the questionnaire. Some questions are found irrelevant, they can be deleted, and if some questions have to be included, the same can be done. Pre-testing must be done with almost utmost care. Otherwise, unnecessary and unwanted changes may be introduced. If time and resource permits, a second pre-testing can be also done to ensure greater reliability of the results. And this all has to be done, is done in-house. Then comes editing primary data. Once the questionnaire has been filled and the data is collected, it is necessary to edit this. Editing of data should be done to ensure completeness, consistency, accuracy, and homogeneity. Completeness. Each questionnaire should be complete in all respects. That is, the respondent should have answered each and every question. If some important questions have been left unanswered, attempt should be made to contact the respondent and get the response. Consistency. Questionnaires should also be checked to see that there are no contradictory answers. Contradictory responses may arise due to wrong answers filled up by the respondent or because of carelessness on the part of the investigator in recording the data. Third one is accuracy. The questionnaire should also be checked for the accuracy of information provided by the respondent. It may be pointed out that this is the most difficult job of the investigator and at the same time the most important one also. Homogeneity. It is equally important to check whether the questions have been understood in the same sense by the respondent. For instance, if there is a question on income, it should clearly be stated whether it refers to weekly, monthly, or yearly income. If it is left ambiguous, then the respondent may give different responses and there will be no basis for comparison because we may take some figures which are valid for monthly income and some for the annual income. Then comes sources of secondary data. The sources of secondary data may be divided into two broad categories, published and unpublished. Published sources are the number of national and international organizations which collect statistical data and publish their findings in a statistical reports periodically. Some of the national organizations which collect, compile, and publish statistical data are Central Statistical Organization, that is CSO, National Sample Survey Organization, NSSO, Office of Registrar General and Census Commissioner of India, Labor Bureau, etc. And some of the international agencies which also provide valuable statistical data on variety of social, economic, and political events are United Nations organizations, UN, World Health Organization, WHO, International Labour Organization, ILO, International Monetary Fund, IMF, World Bank, etc. Then the second part is unpublished sources. All statistical data needs not to be published. A major source of statistical data produced by government, semi-government, private, and public organization is based on the data drawn from internal records. This data is based on internal records provided authentic statistical data and is much cheaper as compared to primary data. Some example of internal records include employees' payroll, the amount of raw materials, cash receipts, and cash book, etc. This remains in the organization itself. What are the precautions in the use of secondary data? A careful scrutiny must be made before using published data. The user should be extra conscious in using secondary data, and he should not accept it at all on its face value. The reason may be that such data is full of errors because of the bias, inadequate sample size, error of definitions, and computational errors, etc. Before using such data, the following aspects should be considered. Number one, suitability. The investigator must ensure that the data available is suitable for the purpose of the inquiry on hand. The suitability of the data may be judged by comparing the nature and scope of investigation. Second one is reliability. It is of utmost importance to determine how reliable is the data from the secondary data and how confidently we can use it. In assessing the reliability, it is important to know whether the collecting agency is unbiased. Third one is adequacy. Data from secondary sources must be available, but its scope may be limited, and therefore this may not serve the purpose of investigation. The data may cover only a part of the requirement of the investigator or may pertain to some different time period. Only if the investigator is fully satisfied on all of the above mentioned points, then only he should proceed with this data as a starting point for the further analysis. Then comes Celsius and sample. When secondary data is not available for the problem under study, a decision may be taken to collect primary data through original investigation. This original investigation may be obtained either by Celsius or complete enumeration method or by sampling method. When the investigator collects data from each and every item in the population, it is known as Celsius method or complete enumeration survey. But when the investigator studies only a representative part of the total population and make inferences about the population on the basis of this study, this is known as sampling method. In both the situations, the investigator is interested in studying some characteristics of the population. The advantage of Celsius method is that information about every item in the population can be obtained. Also, the information collected is more accurate. The main limitation of the Celsius method are that it requires a great deal of money and time. In most cases, it is not necessary to study every point of the population to draw some inference about. If a sample is representative of the population, then our study of the sample will yield correct inferences about the total population. It should be noted that out of the Celsius and sampling method, the sampling method is much more widely used in practice. There are several methods of sampling which would be discussed in detail in sampling methods topic. Now, second, data has been collected. Now, the second part comes presentation of the data. Presentation of data can be displayed either in tabular form or through charts. In the tabular form, it is necessary to classify the data before the data is tabulated. How it can be done, how it is done, how the processing of the data will be done. Here we will study in two sections. First one is classification of data and second one is charting of data. So as far as classification of data is concerned, after the data has been systematically collected and edited, the first step is presentation of the data. Classification is the process of arranging the data according to the points of similarities and dissimilarities. What are the objectives of classification? The principal objective of classifying data are to condense the mass of data in such a way that salient features can be readily noticed. Number two, to facilitate comparison between attributes and variables. Third one, to prepare data which can be presented in tabular form. Fourth one is to highlight the significant features of the data at a glance. Now we'll see what are the different types of classification. Common types of classification are geographical, which is related to what is as accordance with the area or region of the study. Chronological order, that is order of occurrence of the event with respect to time. Qualitative, it is according to the attributes, and quantitative, that is according to the magnitude. Geographical classification means that the data is classified according to the area of region. For example, when we consider population of rice state twice, this would be a geographical classification because we have to find out the states where rice production is done. Chronological classification is when it is according to the time of its occurrence. For example, sales figure for a company for the last 6 years. Qualitative classification is when the data is classified according to some attributes, that is distinct categories, which are not capable of measurement. For example, we may classify population on the basis of employment, that is employed and unemployed. Quantitative classification is that which is done according to some characteristics that can be measured. For example, the employees of a company can be classified according to their monthly salaries. Quantitative data may further be classified into one or two types, that is discrete or continuous. Discrete data refers to a quantitative data that is limited to integer numerical value of a variable. For example, the number of employees in an organization or the number of machines in a factory are example of discrete data because this will be a fixed number. Continuous data, it takes integer as well as fractional value of the variable. For example, the data relating to weight, distance, and volume are example of continuous data. When the data is arranged into groups or categories according to conveniently established division of the range of the observation. Such an arrangement in tabular form is called as frequency distribution. In a frequency distribution, raw data is represented by distinct groups which are known as classes. The number of observations that fall into each classes is known as its frequency. When the data is described by continuous variable, it is called continuous data. And when it is described by a discrete variable, it is called as discrete data. Now we can see here how we can distinguish between. We normally use the right side table. But what is discrete frequency distribution here? Number of employees and number of companies, because the number of employees is fixed. In continuous frequency, we are taking a group that is 20 to 25 and the number of workers are 50. And from the age group of 25 to 30, number of workers are 22. And for 30 to 35, the number of workers are 30. So this is continuous frequency distribution. Normally, we work on this data. Now, how this discrete frequency distribution is made? We said that we have a raw data. Now we have to convert into some form of table. So first of all, we will place all the values in ascending order. We will make or we will use tally marks to count the number. For that, we have 4 perpendicular lines inclined by. The 5th line is by the inclined line. That means it consists of 5 figures. Now we consider a sample study in which 50 families were surveyed to find out the number of children per family. So this data was obtained. Now we will convert it. This data, we will start We will see from this data the lowest number. Lowest number is 0, that means no child is there. And the maximum is 6. So on the tabular form, you can see that number of children starting from 0 to 6. Then we have number of families over there. And we will, the third column will be of its frequency. Now how it is drawn. We will pick up number 3. So number 3 will come in the fourth column. And all these data will be converted into number of families form with the form of tally marks. And after that, on the third column, we will write a total. So we can see 4 parallel perpendicular bars, 4. Similarly, 9, 10, 12, 7, 6, 2. When we total it up, it comes out to be 50. Now, second part is construction of continuous frequency distribution. In constructing the frequency distribution for continuous data, it is necessary to classify some of the important terms that are frequently used. Number 1, class limit. Class limit denotes the lowest and the highest value that can be included in the class. The two boundaries, that is the lowest and the highest of the class, are known as the lower limit and the upper limit. For example, 60 to 69. 60 is the lower limit and 69 is the upper limit. Second one is class interval. The class interval represents the width, span, or size of the class. For example, if the two classes are 10 to 20 and 20 to 30, the width of the class interval will be the difference between the two successive lower limits. That is 20 minus 10, that is 10. Class frequency. The number of observations falling within a particular class is called its frequency. The total frequency, the sum of all the frequencies, indicates the total number of observations considered in the given frequency distribution. Class midpoint. Midpoint of the class is defined as the sum of the two class limits divided by 2. If we have a class limit of 10 to 20, so we will add 10 plus 20 is 30, 30 divided by 2 is 50. That means the class midpoint will be 50. Then comes, there are two types of class intervals. So the first one is exclusive and inclusive method, and the second one is open-end. Exclusive method, the class intervals are so arranged that the upper limit of one class is the lower limit of the next class. The figures on the right side, you can see that it's 20 to 25, then 25 to 30, then 30 to 35. Here 20 firms have a sales between 20,000 and 24.99. The firm with sales of exactly 25,000 would be included into the next class. But this is what we have to keep in mind. If we write it in the form of inclusive method, here it will be the same thing, will be in the form of 20 to 24.999, and the next class will start from 25, and its upper limit will be 29.99. Next class will start from 30. What are the guidelines for choosing class interval? Because the data will be a massive data and we have to convert it into particular form for presentation. So first of all, we have to see the number of classes. It should be between 5 and 15. The width of the class should be a simple like 5, that is 0 to 5, 0 to 10, or 0 to 25. Classes should have equal width. So next class will have the same difference. The starting point of the class should either begin with 0 or 5 or a multiple. It should not start with 3, 2, 7, 8, etc. It should start with 0 or 5, 10. Class interval is found by dividing range by the number of classes. Again, we are taking up that question. Here the 50 employees we have drawn the center one earlier. Now we are taking up the age groups. We are talking about in this particular problem of the ages of 50 learners. So what we will see, what is the lowest number and what is the highest number. From there, as we have already discussed, that it should be from a multiple of 5 or multiple of 10. So here we start with 20 and we take up a difference of 10. So 20 to 30, 30 to 40, 40 to 50, 50 to 60, and 60 to 70. And from there, at the top, we will drop the tally marks. And then we will find out the frequency. So our assumption or our understanding is that there are 7 employees which are of the age group between 20 and 30. And there are 16 workers or employees who are between the age of 30 to 40. So the data from the top we cannot find out. So converting this into some tabular form, mathematical tabular form, we can see from the right last column that what is the exact age. And there from 50 to 60, we can see there are 9 employees which are of this age. And above 60, there are 3. Then comes another analysis, what is required. That is cumulative frequency. Normally, learners make errors in including or concluding or drawing this, finding cumulative frequency. The cumulative frequency of the given class interval represents the total of the previous class frequency, including the class against which it is written. Now we will see to it that from 1000 to 1200, there are 5 employees. So its cumulative frequency will be 5. But when we come to the second class, that is 1200 to 1400, number of employees are 50. And the cumulative frequency will be 10 plus 5, that is 50. That means we can say that from 1000 to 1400 monthly salary, there are 15 employees. Similarly, for 14 to 1600, it will be 15 plus 25, which will be 40. And for the last one, it will be 40 plus 10, that will be 50. But remember one thing, the last value of the cumulative frequency and the sum of the frequency will be the same. Next part is relative frequencies. If the frequency of each class is divided by the total number of observations, then this proportion is referred to as relative frequency. To get the percentage of each class, multiply the relative frequency by 100. What we will be doing, we will be dividing each 5 by 50, 10 by 50, 25 by 50, 10 by 50. And when we will be adding up the relative frequency, we will get there are some things which after calculation we can see that whether we have evaluated correctly or not. The answer will be 1. There are 2 important advantages in looking at relative frequency instead of absolute frequency in a frequency distribution. First one, relative frequencies facilitate the comparison of 2 or more than 2 sets of data. Second one, relative frequencies constitute the basis of understanding the concept of probability. Later on, this probability part will be introduced. Now the data has been analyzed. Second part comes charting of the data. Charts of frequency distribution, which cover both diagrams and graphs, are useful because they enable a quick interpretation of the data. A frequency distribution can be represented by a variety of methods. 4 popular methods of charting frequency distribution are used, and they are bar diagram, histogram, frequency polygon, Kochaev or cumulative frequency curve. Bar charts can be simple, 3-dimensional, or stacked. Depending upon the data, we can use these 3 types of bar charts. Simple bar chart, demerit, but data no longer available for further analysis. From there, we cannot do any analysis. Merit, it is friendlier. Greater immediacy pattern can be easily visible with 3-dimensional or stacked bar charts. Here we can see that if we have to find a conclusion from this, so here we can say that in the year 1997, company produced more than 2,500 fans. That's it. Nothing else can be elaborated from here. Then comes histogram. One of the most commonly used and easily understood methods for graphical presentation of frequency distribution is histogram. A histogram is a series of rectangles having areas that are in the same proportion as the frequency of the frequency distribution. Frequency polygon. We have drawn the histogram. What we will be doing? We will be simply joining the midpoints with a straight line. On the left side of your screen, you can see that a histogram has been drawn, and we are connecting the midpoints by a straight line. Top. A frequency polygon is a graphical representation of frequency distribution. A polygon is a many-sided closed figure. The frequency polygon is constructed by taking the midpoints of the upper horizontal side of each rectangle on the histogram and connecting these midpoints by a straight line. In order to close the polygon, an additional class is assumed at each end having a zero frequency. There you can see that this line from 80 to 60 at the top of the histogram is coming and it's being joined at the center between of 74 and 80. And similarly on the right side, from the histogram bar of 110 to 116, that point has been extended to center of 116 and 120. After the histogram has been removed, we are left with this. This is a frequency polygon. The histogram is usually associated with discrete data, and a frequency polygon is appropriate for continuous data. But this distinction is not always followed in practice, and many factors may influence the choice of the graph. A frequency polygon and a frequency curve have a special advantage over the histogram, particularly when we want to compare two or more frequency distributions. Next, we will move to ogive or cumulative frequency curve. Maximum learners do not remember or do not know that this ogive is related to cumulative frequency. An ogive is a graphical representation of a cumulative frequency distribution. And therefore, when the graph of such distribution is drawn, it is called as cumulative frequency curve or ogive. There are two types or two methods for constructing ogive. First one is less than ogive, and the second one is more than ogive. We'll see. In less than ogive, the upper limit of the various classes are taken on the x-axis, and the frequencies obtained by the process of cumulating in the precedings frequency on the y-axis. And in more than ogive, similarly, more than ogive or cumulative frequency curve can be drawn by taking the lower limit on x-axis and cumulative frequency on the y-axis. We'll see how this is. This data is given to us. Marks 0 to 4, frequency is 4. Cumulative frequency for that class will be 4. For the second one, it will be 6 plus 4, that is 10. For third, it will be 10 plus 10, that is 20. For fourth, 20 plus 8, 28. And for the last one, it will be 28 plus 4, that is 32. When we will be adding up all the frequency, we will be getting a sum of 32. This has to be checked. Now, how to plot it and how we will get a less than type ogive. First of all, we have to see what is the upper class limit of the first one, that is 4. Second is 8. Third one is 12. Fourth is 16. And the last one is 20. What is the respective cumulative frequency? 4, 10, 20, 28, and 32. The points what we are supposed to plot is 4, 4. That means on x-axis it will be 4 and y-axis it will be 4. Normally what we do, or we take marks on the x-axis and cumulative frequency on the y-axis. So when we will be plotting this, we will get this type of graph, which is known as less than type ogive. Here we have taken upper class limit. And the second one, we will take the lower class limit. So it will come from top to bottom. The shape of less than ogive curve should be a rising one, this one, and for the shape of the more than ogive curve should be falling one. Now, what else, what interpretation can be done? The question arises, why we draw this? Now, we have taken another problem. We just transformed it into the same form with the less than method and more than method. Concept remains the same. The more than is coming from top to bottom and the less one is going from bottom to top. Where these two lines meet, that is mathematically or graphically, that is known as the median of the data. We'll see what median is. Median of the data. Just remember where ogive curves meet, both the ogive curves meet, that is the median of the data. Third part, we will move to measure of central tendency. Central tendency means something which is related to center. Statistical methods for summarizing and describing data. We'll find out one representative value which can be used to locate and summarize entire set of varying values, and central value around which the data tends to cluster. What is the significance of measures of central tendency? This condenses the mass of data in one single value to get an idea of the entire data. Individual income of 1,000 persons versus average income. Second one is compare two or more sets of data. Sales figure of August versus another month. This is how we interpret it, how we can use it. What are the properties of good measure of central tendency? A good measure of central tendency should possess, as far as possible, the following points. It should be easy to understand. It should be simple to compute. It should be based on all the observations. It should be uniquely defined. It should be capable of further algebraic trees. And it should not be unduly affected by extreme values. We will see how these 6 points are kept in mind when we are analyzing the data. Following are some of the important measures of central tendency that are commonly used in business and industry. First one, arithmetic mean. Second one, weighted arithmetic mean. Third one is the median, what I said over there. Fourth one is quartile. Next one is mode. Then comes geometric mean, and then harmonic mean. These all parameters have their application in industry and business. We will start with arithmetic mean. These are the different formulas which are used depending upon the data given to us in the problem. The mean is sum of all the scores divided by the number of scores. That is simple. You sum of all the observations divided by number of observations. It is denoted by a summation. Summation, this what sign you can see, that is summation, adding up of all the observations. The second formula is there where we have frequency. So it is fx. We will see to it how it is evaluated. And the third one is with the data is numbers are big. So we assume something. So here in that case, it becomes a formula of x bar equal to a plus summation fd upon n into I. These all values have some significant meaning. X bar is the population, n is the number of scores, a is the change in origin, that means what we have assumed, and I is the change in scale, that is the difference between the two values. Now we will see. Now what are the properties of arithmetic? The sum of the deviations of the observation from the arithmetic mean is always 0. Symbolically, it is written as summation of x minus x bar. When we will sum it, it will always be 0. Number 2, the sum of the square deviations of the observation will be mean, will be minimum. This won't be 0. It will be minimum. The arithmetic mean has the greater advantage of being easily computed and readily understood. It is due to the fact that it possesses almost all the properties of good measure of central tendency. No other measure of central tendency possesses so many properties. However, the arithmetic mean has some disadvantages. The major disadvantage is that its value may be distorted by the presence of extreme values in a given set of data. And minor disadvantage as well when it is used for open-ended, since it is difficult to assign a mid value for the open-end class because 50 to infinity. So 50 to infinity, for that infinity we don't have the upper limit. In that case, it will be difficult to evaluate the arithmetic. That is its disadvantage. Now we will see how to compute arithmetic mean. This is the data which is given to us. We will convert it into how the computation of arithmetic mean is equal. First of all, there are different methods. So we will be talking about two methods. And I will be telling you what is the difference between two methods. No doubt we will be getting the same answer. First of all, we have to find out the midpoint. Midpoint is evaluated by 300 plus 350 divided by 2. This comes out to be 325. You can see that we don't have to make it evaluation every time. You can see what is the difference between 300 and 350. It is 50. Add 50. 325 plus 50, 375, 375 plus 50, 425. And at the last, you will see that it comes out to be 725. The formula you have seen over here, this is summation, second formula, that is summation fx upon n. We will be using this formula over here. We will be multiplying fx. The right side, you can see multiplication has been done. We will add up all. So we will get 102,000. And the summation number of firms, that is summation of all, is 200. This comes out to be the mean as 510. So going back to the data, you can see that it comes out to be the center of the data what was given to us. Now, we will be using another method for evaluating the same. That is, we will be using the third formula, that is x bar equal to a plus summation fd upon n into I. Why? In the last column here, you can see that the numbers, the multiplication is too big. We are getting too big numbers. Now, what we will be doing? We have already evaluated column number 1, 2, and 3. We will pick up a value in the midpoint, which is at the center of the data. That comes out to be 525. In the fourth column, you can see that it is x minus 525 divided by 50. That is the difference of the class interval. That is your d. Mathematically, what is going to happen? The row in which you have assumed a, straight away write 0. And over it, write minus 1, minus 2, minus 3, minus 4. And below 0, write 1, 2, 3, 4. You can evaluate it. I'm just telling how to save time. At the top, it will be minus 2, minus 1, minus 2, minus 3, minus 4. And below it will be plus 1, plus 2, plus 3, plus 4. Multiply f into d. Now on the right side, right column, you can see these numbers are 2-digit numbers. Fine. Add up. Summation fd will come out to be minus 60. And you have n as 200. Go back to the formula, x bar is equal to a plus summation fd upon n into I. Your a is 525, which is marked red in the box. Your summation fd is minus 60, n is 200, and the class interval I is 50. After evaluation, you are going to get the same answer as 5. Again, at the center of the. Then comes median. Second major central tendency is the median. Median is that value which divides the distribution into two equal parts. That means 50% on the right side and 50% on the left side. 50% of the observation in the distribution are above the value of median, and another 50% of the observations are below the value of median. The median is the value of the middle observation when the series is arranged in order of size or magnitude. If the number of observations are odd, then the median is equal to the number of original observations. And if the number of observations is even, then the median is the arithmetic mean of the two middle observations. We will see later in the problem. What are the mathematical properties of the median? Median is less sensitive to extreme scores than the mean, better measure than the mean for highly skewed distribution. We'll see to it what skewed distribution means. The major disadvantage of median is that further mathematical treatment cannot be done. However, since median is a positional value, its value is not determined by each and every observation. The important mathematical property of median is that the sum of the absolute deviation, absolute means we won't be considering plus minus sign, about the median is minimum. That means when we will be submitting up, we will get a minimum number. When there is an odd number of numbers, the median is simply the middle number. You can see we have three numbers, 2, 4, 7. We will arrange them in the ascending order. We will get 2, 4, 7. That means 4 will be the median. But when these observations are even number, the observation becomes 2, 4, 7, 12. So we will pick up two middle values, that is 4 and 7, add them and divide by 2. In that case, the median will be 5.5. We have a mathematical formula to evaluate median when the data is big one. So here we have to remember this formula because this is the basic formula from where further studies will be made. M median is equal to L plus N by 2 minus PCF upon F into I. Now the question arises, what is this? PCF is, what is F, and what is I? And what is L? L is the lower limit of the median class. PCF is the preceding cumulative class, the cumulative frequency of the median class. That means, remember, in case of evaluating median, you have to evaluate cumulative frequency. F is the frequency of the median class, and I is the size of the median class. The class which has cumulative frequency just greater than n by 2 will be the median class. Then comes mode. Mode is the most frequently occurring score in the distribution, greatly subject to sample fluctuation, and is therefore not recommended to be used as the only measure of central tendency. A further disadvantage of mode is that many distributions have more than one mode. These distributions are known as multimodal. For example, in the series of numbers 3, 4, 4, 5, 6, 8, 8, 9, the mode is 8 because it is occurring maximum number of times. From the data, you can see that only 8 is occurring 3 times. No other number is occurring more than. That means we can say that mode is the 8. Again, when the data is big, we have to use a mathematical formula for it. Modal class, it is the class which contains the highest frequency, because mode is related to frequency. We have a formula of MO is equal to L plus F0 minus F1 upon 2 times of F0 minus F1 minus F2 into H or I, whatever you want to take. Lower limit of the L is the lower limit of the interval containing the mode, that means the highest frequency. Width is the difference between the interval. N is the total number of respondents. F1 is the frequency of the preceding modal class. F is the number of cases in the interval containing the mode. And F2 is the frequency of the class containing following the median class. And there is an empirical relationship between mode, mean, and median. If we know mean and median, we don't have to apply the formula for evaluating mode. We can use this mode is equal to 3 median minus 2 mean. Now we will see how it is evaluated. During the conduct of a research study involving a group of 40 library staff, the following scores on library aptitude tests were obtained. You are being asked to evaluate all the three things, all the three central frequencies. That is mean, median, and mode. From this data, we will convert it into a single table, which will let us know how the evaluation is done. We'll make class interval, frequency, cumulative frequency, mid value, and effects. This is normally what is required throughout. So the question was how to evaluate cumulative frequency. Here you can see that by red arrows it has been provided to you how it is evaluated. 45 plus 20 you will get 65, 65 plus 14 you will get 79, and in the last column it will be 89, which will be equal to sum of all the frequencies. Next you have to find out the mid value. Mid value of 0 to 10 will be 5. The difference is 10. Add up 10 to all. 5 plus 10 is 15. 15 plus 10, 25. Come up to 45, sorry. Then multiply fx. Now, evaluate n by 2 also, because n by 2 will be used for median. It comes out to be 44.5. We are talking about the frequency. Now, first of all, we will evaluate mean. X bar is equal to summation fx upon n. Summation fx is 1255 divided by 89. We will get 14.10. Median. For the median class, we have to find out n by 2. N by 2 is 44.5. In which cumulative frequency it is coming? More than 44.5 is 45. That means your class is 0 to 10. Median L plus n by 2 minus PCF upon F into I. Now here, the lower limit of the median class is 0. N by 2 is 89 by 2. Preceding class cumulative frequency. The frequency over 45 is again 0. And the frequency of the median class is 45. And the difference is 10. After evaluation, you will get 9.89. Now, we have evaluated mean, we have evaluated median. We won't be using the mathematical formula, but we will, in spite of that, we will be using empirical formula to evaluate mode. That comes out to be mode equal to 3 median minus 2 mean, which is 3. We have evaluated median as 9.89 and mean as 14.10. After evaluation, we'll see that it comes out to be 1.47. We have evaluated mean, mode, and median through in a problem. Then comes locating the mode graphically. Median, we have seen that this can also be evaluated. In a group data, the value of mode can also be determined graphically. In graphical method, the first step is to construct histogram of the given data. Normally, how histogram is drawn, we have already discussed. The next step is to draw the two straight lines diagonally on the inside of the model class. Model class is that class of the highest frequency. So what we will be doing? We will be joining the ends, starting from each upper corner to the bar on the adjacent bar, where these two lines will be crossing. We will draw a perpendicular line on the x-axis. The point it meets x-axis, that will be the model value, which comes out to be approximately 35. Sorry. That means its mode is, we have not evaluated anything. By the graphical method, we have evaluated that the mode is 35. The chief advantage of mode is that it is by definition the most representative value of the distribution. For example, when we talk of the model size of shoe or garment, we have this average in mind. Like median, the value of mode is not affected by extreme values, and its values can be determined in open end distribution. The main disadvantage of mode is its intermediate value. That is, we cannot calculate its value precisely in a group data, but merely estimate it. When a given set of data have two or more than two values as maximum frequency, it is a case of bimodal or multimodal distribution, and the value of mode is not unique. Mode has no useful mathematical properties. Hence, in actual practice, the mode is more important as a conceptual idea than as a working average.